Okay, so just as a general cover of a workflow from Rhino to Unreal Engine with some kind of in between little tips and tricks. If there's any questions or kind of further ideas, then feel free to get in touch as always. Um, but obviously, before we start pre Unreal Engine, I think there's a couple of things to cover. Generally speaking, I mean, in Rhino, it's kind of the one software that I tend to bounce back and forth to. And so I've just modeled kind of a very basic scene. The idea being that there's multiple elements of a site. In reality, when you are modeling, you're likely to be using kind of layers in very specific ways. However, for kind of rendering purposes, the general workflow is to separate layers based on material. So then in Rhino, you can very quickly select the same material with the same layer and then assign it via the materials. Which very nicely leads myself onto kind of materials as a whole. Rhino does have kind of a series of materials, some of which are kind of nice, however, a lot of them leave a little bit to be desired. And so kind of the general idea is that instead of using Rhino materials, we use PBR materials, sorry, physically based rendering materials. And these materials you tend to find online, and kind of one of the websites that I tend to use is SketchUp Texture Club, and they kind of have a whole list of PBR textures as well as normal textures. The difference being PBR textures will have different maps. So in this case, if I open up textures, if I open up a previously downloaded texture, you see that there's a diffused layer, which is literally your color. Then there's a displacement layer, which is kind of a rough where things should go. And then there's this thing called the normal layer, which indicates to the texture how bumpy things should be. This normal layer will always be kind of a blue purple color, and then you have kind of different layers that make a material other than kind of just a texture that's applied on top. The only thing in Rhino that's worth talking about, kind of there's two things. One, which is when you have multiple geometries, like in this case, that ideally would have the same material. The most useful thing is obviously to Boolean union them. So using the command Boolean union, merge them. Essentially, that makes one kind of bigger geometry. That's a lot easier to handle computationally. And then in Unreal, what usually happens is that all the geometries get split up because people tend to animate specific geometries. However, if you have one big blocky geometry, it's kind of useful to do this. The other command, and I'll switch to shaded view, is merge all coplanar faces. And essentially all that does, if I get a side by side, is places where two surfaces are coplanar, aka they're in the same plane. Running this command basically puts him as one big surface. So in this case, if I was to once again create a physically based material, let me call this terrazzo. In Rhino, you kind of go to detail settings, and then you can add different specific layers. So in this case, I'm going to add a base color, which will be my sometimes it's called diffuse layer, but sometimes called base color. It depends from kind of engine to engine. And then in this case, because I actually have access to things like normal maps, I will also click here for a bump / normal, which is this guy. And in fact, I also have a displacement map. And to go all the way in, I'll also try and add a specularity. Oh, I also didn't see that we also have apparently a AO, so this would be kind of ambient occlusion map. It's kind of relating on how the geometry, how the texture kind of reflects. But now that we have this kind of nice material, kind of nicely put together, we can kind of just click, drag it, assign it to our geometry, and in this case, I'll try and assign it to all geometries by just clicking and dragging. And hopefully now it's switched to rendered view, once Rhino decides to switch the view, you should see kind of a difference between these textures. I'm going to, I think what's happened here, sorry, I just quickly deactivated a layer the moment I saw this. For some reason I could have accidentally placed this layer as a displacement map, and essentially all that did was kind of really displace the geometry, when in reality it should have not done that. So if I just reassign the layers, there's not a huge difference between kind of the merged coplanar surfaces and non-merged ones, but in places like this, where there's the seam that would otherwise not be there, you start seeing a seam, which in this case that doesn't really happen. And obviously with all your geometries being separate, there's kind of all sorts of different mapping issues that happen. Usually kind of as an umbrella kind of coverage, in texture mapping in Rhino, we tend to kind of just use box mapping as kind of the biggest way of mapping, and that essentially all that this does is it assumes that it generates a bounding box about the size of your geometry, and then it maps based on this bounding box as opposed to individual boxes. This tends to work a little bit better for kind of irregular surfaces like kind of these guys, but as you can see here with just a surface mapping which essentially maps to each individual surface, it also works just as well. If I temporarily go back to surface, one of the things that will happen a lot of the time, especially if we deal with photogrammetry scans that aren't completely to scale, as you can see these terrazzo tiles, well, I haven't assigned this sculpture a scale, but ideally this wouldn't be kind of the texture you'd see in terrazzo. This is when there's all these conversations with your tutors about kind of the scale of a material and whether or not you actually want to put your foot down on a specific material. I was kind of always told that you should imply a material as opposed to kind of really pick and go with something that looks very literal, like a very literal interpretation of a material. Having said that, there are, in the texture mapping part of Rhino, there are a few kind of changes that you can make to kind of scale this texture, specifically in the UV wrap repeat section. So if I just lock this to make sure that it's scaling evenly, if I change this to 10, as you can see now it's kind of much more finely repeated all throughout. A lot of the times with things like timber, you want the grain to kind of align with your geometry, and this is when you use your UV rotation. A lot of the times it's a matter of kind of rotating by very subtle angles until something really works, and sometimes something really doesn't work. A lot of the times you might come across an issue where, because your geometry isn't quite scaled, you'll get something that looks like this. At first when you apply material, everything is kind of one solid color. The trick is to kind of either really zoom in to realize that it's kind of a random size, or have a look at what size the texture is brought in as versus what you're scaling at. Sometimes the texture is brought in to the assumption that it's meters, whereas you're working in millimeters, and vice versa. Sometimes you might get a texture that also looks like this with no apparent reason, but a lot of times it's to do with scaling. That's the Rhino side of things. However, there is kind of a tiny little step between Rhino and Unreal that is slightly more advanced workflow. The file type that most times you'll be exporting with is FBX. So if I just export this temporarily to, let's call this O2, is FBX, which is under Motion Builder. And essentially what this does is, and I've kept these kind of as default, essentially it packages your geometry with texture all as one file, whereas if you export something like an OBJ, it will split the texture, and so you have 3 files when you export as an OBJ, which is the OBJ itself, an MTL file and a texture file, whereas an FBX, it's literally only one file, and Unreal Engine has a much easier time to read that. The other thing for kind of a slightly more advanced workflow, there is a plugin for both Unreal Engine and Rhino, which I'll kind of touch on what plugins really are in Unreal Engine. But the Rhino side of things is this plugin called Datasmith. And what this allows you is, which I've very conveniently added to my version of Rhino, it allows you to synchronize models with direct link with Unreal Engine. But in my case, what I tend to do is export models as 3D views. And this literally makes one big file similar to an FBX, but in the event of an FBX that you have different geometries, it will export them as different geometries. And that can get a little bit messy, figuring out different versions of models, etc. Whereas with Datasmith, which is pretty straightforward to kind of sign up and download, it's really easy to kind of just export everything that's seen, or deleting some areas and exporting whatever you want as a kind of Datasmith file. But that's kind of the Rhino side of things. The Unreal Engine part really begins with kind of how to download. So Unreal Engine comes packaged with kind of Epic's game launcher, which is kind of the marketing side of things, and this other thing called Fab, which before was called Sketchfab, but now it's called Fab by itself. So you first have to download kind of the Epic Games launcher, but the moment you go into kind of Unreal Engine and library, you should have the option to kind of select multiple versions of Unreal Engine. Essentially, when it comes to Unreal Engine versions, anything above 5.1 tends to be quite good. Even a lot of kind of the earlier Unreal Engines like 4.4, 4.1 all work very well. In the 5, I personally use 5.4 because they added a couple of things to do with lighting that I quite enjoy, but these are kind of very specific use cases. A lot of the times, you see a lot of game developers tend to avoid the earliest or earlier versions of Unreal Engine, just because a lot of the times you're sending files to each other, and therefore having a slightly outdated version is a lot easier. So yeah, I tend to stick with 4.4, 5.4, but that's kind of just kind of a personal choice. So I'll launch kind of just the generic Unreal Engine. And one of the nice things with Unreal Engine as a whole is that it comes with a lot of templates that are kind of useful from the get-go. A lot of other kind of game engines, you're required to do a lot of stuff from scratch, which isn't always the easiest, especially if there aren't a lot of tutorials online. Whereas literally the moment you launch Unreal Engine, it has all these kind of different templates, a lot of which are architecture related, and some of which are even kind of VR related, and this is essentially like a game ready VR template that you can add your assets and kind of do VR or mobile AR. But for a lot of times, a lot of animations, the template that I tend to kind of recommend and even go with is the architecture visualization template. So yeah, if you kind of click on this one as a suggested one, you can save it to somewhere specific, and very similar to a baking show, I've already started kind of a version of the starter file here. So if Unreal Engine lets me have a play, essentially when you do open it, you'll see a very kind of similar world, and I'll quickly guide you through the UI. Essentially, if you right click, it lets you move your camera side to side. If you right click and use the WASD keys, a bit like a video game, you can move around, and then using the Q and E keys, that should let you go kind of up and down, and that essentially lets you control in a slightly more intuitive way, perhaps for gamers, where cameras are, where you're moving around. You see up here, similar to Rhino, you are able to click on things and you see a gumball, but unlike Rhino, up here you have kind of different tools that you can use. So you have kind of rotation tools, scaling tools, and they work very similar to kind of Rhino in the sense of a simple gumball that lets you do different things. But that should let you move kind of and do all these other scales. By default, these three are turned on, and these are kind of same as kind of the Rhino snap to grid or snap to orthographic. For the most part, I tend to leave them off because I'm not snapping to specific angles. A lot of the visualization work tends to be kind of free flowing and kind of what looks right. Sometimes moving a building slightly down or slightly up feels better than to kind of go by a specific grid. Last is camera speed. Essentially is asking how fast do you want to move around. A lot of the times you're doing very precise camera angles, especially for interior shots, and this is kind of the default building that came in this template. But essentially you should be able to click it and kind of drag this thing up and down, or for slightly more control, if you're kind of in your right-clicked moving around camera, you can just scroll up and down, and that's sometimes a little bit more comfortable, and that should let you kind of get very slow, or if you're working on something that's massive, you can really zoom out and have a play around. This template is also very useful because it comes with materials like lighting or general water materials. It also comes with a lot of kind of useful tips, such as how to access the pre-made level sequences, how to use post-processing volumes, which I think I'll cover. And so yeah, I heavily suggest kind of just having a play with this, deleting things that you don't want, kind of seeing what the impact of that on the scene is, bringing them back, having a look at how they actually play a lot of tricks with things like the scenery in the background, the fog, etc. But yes, so to cover the other aspects of the UI, under here you have your content browser. That's basically how you bring things into Unreal Engine before adding them to your scene, aka this kind of bigger thing that you can render and do all these animations in. On the right side, you have this kind of UI that's very similar to Rhino, with all these layers that you can turn on or off. In this case, I didn't turn anything specific. There we go. You can turn the building on or off. And then just below them, you have the details layers, and this contains literally everything about the kind of object you're clicked. But kind of the more important ones is kind of the location and the scale. A lot of the times you end up bringing something from Rhino, which is in millimeters, whereas Unreal Engine is kind of working in centimeters, and so you might have to scale it by 10. The other common issue in Rhino, which I'll briefly cover, is the fact that Rhino believes that there's this huge debate in the kind of gaming computational community about whether or not Z, the coordinate Z, should be upwards, vertical up and down, or if it should be kind of left and right. There's this whole debate because mathematicians see X and Y as your left, right, up, down, and Z as kind of the third dimension. Whereas it is said that a lot of architects drew with sections, and therefore they believed Z was kind of the other direction. So a lot of the times you'll see you might import your geometry and it might be rotated 90 degrees, and that's because Rhino Z wasn't mapped to FBXY for whatever reason. And so with all of this in mind, there's kind of a few tricks that you can also do from the get-go. I'll briefly explain what kind of a lot of these things do. For the most part, a lot of the layers are kind of useless. There's a lot of things like notes that you can read through. There's kind of all these other things that, once again, you can read through. I think the most important ones tend to be kind of environment related. And a lot of the times you can literally click things on or off to see how they work. So in this case, we have an exponential height fog component, and that lets you turn kind of height fog, which is just a general fog. You can also have a play with kind of the density of this fog, how far it stretches, how far it comes close to you, all within this volume, all within this kind of details panel. And then below you have this thing called the post-process volume, Essentially, the way that I like to think of them is like filters in Photoshop. So in this case, there's a huge amount of filters like depth of field, chromatic aberration. Sometimes if you want to have kind of a different effect, you can really add these filters and they get applied to your scene as a whole. There are a lot of YouTube tutorials that have very specific combinations of filters that let you do very kind of very nice things with, say, like lenses flare or how the sun interacts with your camera. And then lastly, we have our sun sky. The way it is set up in here, in this kind of architectural template, is in a very architectural way. It's asking you for kind of latitude, longitude, perhaps of your site, time of the day. So you can do some really nice kind of shadow analysis about kind of solar time, and you can literally kind of pan this, and you have the ability to animate this. A lot of the time, students found some of these parameters slightly confusing, and if that's the case, you can bring kind of your own lights. So Unreal Engine doesn't call things by geometry or nodes, it calls them actors. So you are able to add lighting as kind of an actor. And so if I went kind of up here, which lets you add different characters, different actors, sorry, I can add, say, a directional light, which is kind of how a sun works. And this kind of should let you rotate and kind of do all these scaling things in a slightly more intuitive way at times, in a way which has a little bit more control, essentially as a whole. The other thing that you might have noticed when I turned the lights off, the camera slowly kind of, the exposure started kind of auto-correcting, and the reason for that is because of the post-processing volume having an auto exposure setting on it, which you can turn off as a whole. So all these kind of little point lights that you see are literally that. There's kind of an array of little point lights that you can add all throughout it. So that's kind of, oh, I now have too many lights on. Let me get rid of this one. There you go, everything should be a little bit better. So there's other things that Unreal Engine is also kind of surprisingly good at. Things like foliage, which here is done in my opinion, a really terrible way. But there's kind of little things that I'll cover very quickly. Essentially, you can go into foliage mode. This comes with its own set of very artistic trees that you can add like a paintbrush on a scene and have full control over how many trees, etc. If you do want, excuse me, if you do want your own trees, Fab is the kind of Unreal Engine added way of getting 3D models, and so it's kind of down here right next to the add button. And the really nice thing with Fab is that, which isn't, you don't see a lot of game developers use, is that when you do search for a specific term, say if you're looking for a specific tree or a specific set of foliage, a lot of the assets here are kind of photogrammetry scans of real life places, and some of them are kind of very nicely documented about, say, temperate vegetation, or they have specific tree packs that are specific to European climates, pine trees, birch trees, as opposed to just kind of calling it generic tree. So you can make kind of the foliage that you're looking at very site specific, without it looking too visually kind of demanding or computationally demanding. A lot of the ones that, and in fact the other thing I thought I'd mention, there is a filter in Fab for only look at free things, which for me at least is kind of very useful. So if you go to price, you can look at free assets, and a lot of these assets you'll see written on them kind of game ready, etc., and you see them showing off kind of the amount of polygons. The reason for that being that a lot of these assets are for kind of game development, and therefore there's this kind of idea that they should be optimized in order to not crash your computer. And so a lot of these assets you'll see will be kind of quite light on your computer unless you go really overboard and add kind of a million trees all around your site. A lot of the foliage will also have kind of animations of like the wind passing through, so it can make for some very nice videos and sequences. So that being said, and excuse me once again. Two things to cover. First of all, is how to bring kind of geometry into Unreal Engine, and I'll show you kind of two ways. The first way, well, both ways, I'd suggest always having a folder for 3D geometry in Unreal Engine, and the way I just did that was to right-click the content folder and go to new folder. But overall, there's this kind of add button, and you can just go on top and type import. And what that does is it lets you just find a file and select. The nice thing with FBX files, you can import all, which essentially that means that it will bring the used textures and it will bring your geometry. Now sometimes you might see an error that the textures haven't been brought, at which point you can kind of just import them manually. You can also, if you're not sure where your folders are, you can click and drag from your folders into kind of this content browser. And to add a model in, it literally is a matter of just clicking and dragging. And as you see, we had that same issue of the model being kind of not the correct scale, which is understandable because Unreal Engine deals in centimeters, whereas I was modeling in millimeters. If you can't find an object, which is the command that I just kind of clicked there, I was clicked on the object, and then if you hit the F key on your keyboard, it will try and zoom into your object. So in this case, I'm just going to scale this to scale everything by 10, and obviously in my case of modeling small things, it wasn't quite building scale, so I'll just get it the correct scale. And now, if you want your models to be a direct correlation from what you have in Rhino, you want to make sure that this location is set to 0, 0, 0. In my case, as you see, I was modeling kind of off to the side, and so I'm just going to manually drag that to kind of where this building is, and now replace this slightly ugly building with my sculpture. And that's essentially in how to bring kind of a model, very basic, into Rhino. Now, as you remember that I mentioned before, there's the second route of exporting models using the Datasmith plugin. Now, the Datasmith plugin you need to download onto Rhino as well as Unreal Engine. And to do that, you can go into up here to Edit, Plugins, and search for Datasmith. And there will be a couple of them. My opinion, I always find it easiest to just download kind of, if you don't have them ticked, to download them literally as a matter of just ticking Datasmith importer as well as the FBX importer. Sometimes that tends to help. The C4D, that's Cinema 4D. If you're using Cinema 4D as a modeler, you can also use that. And finally, you can just kind of tick the CAD importer as a whole. It will ask you to restart the editor. Don't worry, kind of everything is saved, or at least it will ask you to save things. And then the next time you come in, you should be able to add an actor, Datasmith, file import. And you should be able to see and import your Datasmith file from Rhino. So the other plugin that I thought I'd mention kind of as a whole, if I go back to edit plugins, is called Cesium. And essentially what Cesium lets you do is, as it kind of implies, it lets you bring Google Earth, Google Maps specifically, into kind of Unreal Engine as an environment. So if you, or when you download the plugin of Cesium, then once you reboot your Unreal Engine, there should be a window that pops up here. If this window isn't here, you can, just like I did, go up here to the window tab and type Cesium, and that will show up. Now it will ask you to connect this thing called Cesium Ion, which hopefully it doesn't crash my laptop. But essentially Cesium Ion, which you can also enter with kind of your Epic Games account or your student Google account, which I have opened here, essentially lets you call Google Maps through an API and essentially use Google Maps in your Unreal Engine. Similarly to before, I kind of have an example of what that looks like, and I'll also in the meantime try and close my browser as to not crash my computer. And essentially in this case there was a lot of this was a VR installation, and so there's a lot of data and we wanted to bring it on site exactly. So this is at the East India Dock, and in this case it also kind of was right across the O2 arena, and this is essentially a map within Google Maps that you can bring into, say, your site for visualizations. A lot of the time, in fact, most of the time, this Cesium plugin is mostly used as a backdrop, kind of how you're seeing it being used now, where there's a, if I find the correct layer, where there's a kind of underlying Rhino model that was modeled in, as you can see, kind of every little bollard, and brought in through Datasmith, and this kind of site used as a backdrop for it to be experienced in VR. The fog component also kind of helps in kind of blending that further in, as well as some kind of fine-tuning with how the lighting interacts. Similarly, you can see a lot of the fab kind of grass and other elements, but a lot of the times in visualizations it's about kind of layering different things that slightly work to make an outcome that works. Obviously there's a few things that aren't quite right with this scene as a demo. Hopefully you have access to the demo video the kind of China studio produced 2 years ago now, with their own Unreal Engine rendering. But in essence, if I try to do this from scratch, if I open through here, should be able to allow, it will then ask, there we go. And in your case, it might ask you to kind of log in or create an account. Once you're here, essentially the tile we're looking for is Google Photorealistic 3D tiles. And the moment you click, it'll ask you for a token. Essentially a token is just a way for them to keep track, to make sure people aren't using crazy amounts of tokens to call Google Maps APIs. And so you can literally create a new token and it's free to use. This does require an internet connection, which sometimes when you're exhibiting, at least for us, became an issue because we didn't have Wi-Fi and therefore it didn't load. And so the VR experience that you saw kind of looked very different. So I'm just going to use a existing token for the sake of this project. And then the moment I clicked, it's created a couple of tabs, and it's also trying to load. As you can see, my computer is slightly struggling, and at the bottom it says preparing shaders. What usually happens is what you're seeing here is essentially, and Unreal Engine is now telling me off for exhausting video memory for having kind of these two files open, so I'll try and get rid of one of them. Hopefully this should go down. Even then. Essentially it loads Google Maps as this massive thing. It shouldn't overwhelm your computer too much. Obviously I have however many tabs open and all these other tasks, which I'm now trying to close, which don't seem to want to close, so it's mostly my browser taking up RAM. Okay, see, now I've closed my browser and this is okay. Essentially, this Google Maps isn't heavy on the computer because it's only really rendering in detail what you're looking at. Everything kind of in the background is kind of very low res. Now, you know kind of the tiles have loaded in when you see kind of this random mountain range. And it generally is a good idea to make kind of a layer or a folder in your editor up here to keep Cesium stuff away from everything else. And the reason for that mostly being because, as you see, it kind of auto-generated all these actors which are needed to maintain Cesium working. Now, the way to get Cesium exactly to where your site is, you'll need to go onto Google Maps. And in this case, I'll pick somewhere random. Here we go. Pick out this farmland and zoo. So if I right click in the map, you see these kind of coordinates. So I'll just click on those, just regular left click, and I'll paste them in the kind of a little notebook. Essentially, one of these is your longitude, the other one is your latitude, and so you'll need to copy them. And in Cesium, you'll see, and this is where I tend to get these guys confused, it will ask you for origin and latitude and longitude. If I paste these numbers in, and once again I might get them slightly wrong, or even the other way around, and this is where zooming in and zooming out becomes really handy. In fact, I will get rid of the fog so I can hopefully see, and it looks like we're above open water, which is an indication that I got the numbers incorrect. And so I'll do them the correct way now. There we go. This is looking more like what we expect. The other thing, so now it currently is setting this kind of origin height very low, and for that it's literally a matter of grabbing this origin height and dragging it upwards until it matches your site height or Unreal Engine's site height. Okay, now we're kind of geolocated. That's your river. Here's this little zoo. And as you can see, obviously, I'm now reducing the speed. Obviously, Google Maps is as good as you can hope Google Maps to be. So with things like trees, with things like very subtle terrain changes, it's not the best. It's kind of a lot better with kind of building skylines, etc. However, this is kind of only the start of the tool. I would encourage you to have a look at how to add things like to window, how to add things like a polygon, and how to use this polygon as a clipping plane to clip out areas of Google Maps that you don't want. Or in fact, Google Maps also has a 2D contour kind of plugin that you can just import. And so a lot of these tools are kind of the starting point of something that you can go along and really explore. This is hopefully just kind of a very basic touching of different tools that you can use. So to kind of develop on these tools, I think the other useful thing is to kind of talk you through basic animations. And animations fall under the term of sequences in Unreal Engine. So the easiest way to do so is to click Add. It would be in Cinematics and Level Sequence. So if I give this level sequence a name, Animation. If I double click, you see, similar to kind of, I don't know if you have experience with softwares like Adobe Premiere, there's literally kind of a timeline that you can scroll back and forth, and there's kind of different tracks here that you can add on the side. There are a lot of tools that you can play with, such as the fact that this by default shows you in frames per second, as is kind of a very gaming related thing, but you are able to change into kind of if it should be per show time as seconds or frames. In this case, should give you a little bit better perspective. This kind of scrolls infinitely, so you can kind of expand and go into hour-long animations if you want to, kind of going back and forth. The first thing that you should do when you're making an animation, obviously, is to add a camera, and it's using this button here, and that just brings in a camera. You see now my editor has these kind of black bars. The reason for that is because you're now seeing your scene, aka kind of what's modeled in, through the eyes of a camera or a simulated camera. In this case, you see in the details settings, it's talking about kind of a 16:9 digital film camera, but this actually has quite a few presets into what kind of camera it should be with its own field of views, if it should be a full frame DSLR, etc. Similarly, there's kind of all these focal lengths that you can play with, and not only can you play with them here, you can also play with them kind of within your animation, so things like focus distance, etc. You can really have a play with. If I, for example, get really close to something through this camera, you can really have a play with things being in focus or out of focus in a very subtle way. And now I'm just moving this parameter back and forth. However, as is with a lot of the other kind of animation softwares, most of the animations in Unreal Engine are based on keyframes. And what keyframes are, essentially they're key points that the software recognizes as kind of points in place and time where parameters are kept. Everywhere else is kind of interpolating between keyframes, and you'll see slightly later on what I mean by interpolating between them. Now, if you do want to make changes, say, to this big model, and you don't want to be in this tiny cramped camera, you can go up here and click this little eject button, and that should get you back up and rolling into kind of this editor mode, with your camera still being kept in place. Nothing has changed about it. If you do want to go back in your animation down here, you can click in here, and now you're in the camera, and by right clicking and moving stuff around, you can still control the camera. So to illustrate the idea of keyframe, I'm going to start my animation by looking at the building from kind of this angle, say, for example. Now, if I really want to be kind of specific about angles and height, the way to make sure that the camera is set at, say, a spectator height is to literally drag the camera until it's at ground level, just sort of visually, and then up here, kind of these values are your X, Y, and your Z. Everyone's Z is going to be slightly different because it depends on where you've modeled, but essentially, let's say if I want to add a meter 80, I add 180 centimeters, and now the camera is 180 centimeters off the ground, if that's what you want to be your starting point. So let's say that I want to start here, and in fact I'm going to grab the time to 0, and what I will do is set a keyframe on the transform component, aka kind of where the camera is, where it's rotated, and I'm just going to add the transform component. Now let's say that 3 seconds later, I would like the camera to be kind of much more up close and looking up. All I need to do is, first of all, drag it to 3 seconds, and then hit another keyframe in the transform, and essentially the software interpolates between those 2 points, and it's now made it into this kind of very brief 3-second long animation. Now, the speeds of this animation, now that you've played it in real time, and you play it by hitting the space key in your keyboard, what I can do is, if I think that 3 seconds between the start and the end of my animation isn't quite nice, I can literally grab this keyframe, the end one, and just drag it on, so now it is, say, 10 seconds. And now, if I drag all the way to the start and hit space, it now is kind of a much slower kind of movement to the camera. However, and now it stops. However, this kind of idea of a keyframe isn't specific to only kind of the transform components. Say, for example, if I wanted my camera to stay in this position for a little bit longer, all that I have to do is either move this keyframe, or just what I've done is Control C, copied, and let's say I want the camera to stay there for 3 seconds. Now, because these two frames are the same, essentially we'll stay there for 3 seconds and then it'll move forwards. The reason why I want it to stay for 3 seconds is because I want to include this kind of unblurring effect that you see a lot of kind of in cinematic videos. And so what I will do is I will change the focus so that it's very blurry, kind of how I would like it at the start of the video. Add the keyframe, and then in fact, for kind of variety's sake, I'm going to make it focused right before it moves. So now the focus is kind of how I like it, and I'm just going to add another keyframe, and now you see that it should stay in place, but only the focus changes. And so if I play it, focus changes, camera begins to move very slowly. And essentially this is the same principle as the demo video that was kind of sent and hopefully shown to you guys. But this isn't limited to camera only. Say if I wanted to add this, my little test FBX to this animation, all that I had to do is literally click, drag it in here, and now I have access to its transform. There are many other things that you can add. If I click on this little plus, you can have a play with all these other things, such as the fact that it's a component, and within that there's all these kind of, I can have a play with its material, I can animate the material of it, I can animate whether or not it's hidden in game, or maybe it'll kind of appear and before a certain time it's kind of vanished. So it vanishes and then for whatever reason, poof, back it is into reality. There's all these kind of different layers that you get to add and turn kind of the sequence into this kind of very finely dialed kind of combination of sequences of things that are moving, things that aren't moving. Maybe you want to bring in your post-process volume and that changes color. You can kind of make all these very subtle color corrections. But that's kind of the animation process of it. A lot of the times you end up probably showing your tutor kind of this scrolling through as opposed to a final polished video. However, to output a video is actually quite easy. If you kind of take this, if you click on the little clipboard here, you can kind of render the video out as a AVI or any other kind of video file that you want. It's worth noting the kind of the resolution. So if I reduce the resolution and say if I bring this to the default value, which usually is 75, if I'm to capture this movie by clicking at the bottom, it will show me a render kind of preview of what the movie is, and hopefully that doesn't crash my computer. But essentially it's worth having a play with all these parameters such as the resolution, but most specifically the resolution and the compression. This should render out relatively quickly, I'm hoping, and with a file that isn't huge. However, you'll see later on that the quality is quite low. And that, in order to increase the quality, you can kind of increase or not use compression and either increase kind of the compression quality and even increase the resolution itself. However, the kind of workflow for rendering things out in practice looks slightly different, which if you do kind of want to advance and explore that, if these files end up being huge files and you can't really manage them, I would suggest looking into this workflow called FFmpeg, which is this kind of little script that you download that attaches onto Unreal Engine, and that should let you output up to kind of 4K plus videos at much slower resolutions, and that's using a plugin called Movie Render. It's technically called Movie Render CLI injection, but once this renders, I'll stop the capture now. Essentially, if I go to edit, plugins, and search for movie, it is Movie Render Queue, and this once again will ask you to restart your Unreal Engine. But what this lets you do, and this is where I think there are a lot of videos kind of finally covering all the parameters online, it allows you to go into your project settings and adding this FFmpeg thing that you download into rendering and lets you output very specific videos. But yeah, that should be kind of a workflow from hopefully going from a Rhino 3D model, something quite easy to model, kind of not crazy, into a full-fledged little animation that can range in kind of different levels of expertise and uses of cinematography. So hopefully that covers it all. Once again, any questions, if there's anything that you saw that I skipped, then feel free to get in touch.